Well, good morning, everyone. My name is Farah. This is Ramsey Dow and our team leader, Rema Ike. We are from University of Houston, and we are Team Mobile Robotic Videographer. So I'm going to jump on to our purpose. What are we trying to do? We are trying to build a robot that's going to follow, track, and film a 5K runner throughout the entire race course. And we want to do it in a safer and more modern method that we currently have. So we ended up building a robot that can track and film a 5K runner throughout the entire race course. It can also follow a GPS track, and while staying on the GPS track, it can keep the runner in frame using human recognition. And now I'm going to pass it off to my teammate, Ramsey.
Okay, so this is our overview diagram, and this is kind of tells us how we're going to accomplish this. So first of all, the RC card, the biggest piece, that's acting as our base for our robot. And there's two major subsystems that we're looking at. First of all, there's the Pixhawk 2.1, and that's kind of like the autopilot, the brain of the RC car. That controls the servo motors, and that's connected to a telemetry module, which allows us to communicate with our ground station, and as well as a real-time kinematic GPS system. And over here, we also have the Latte Panda Alpha, which is a very powerful microprocessor, and we're going to use that to control our custom 3D printed pan tilt system and camera, and that's going to be used for the image processing. Next slide. Okay, so this is kind of like an image I took of our GPS performance, and as you can see, this is a track, and there are multiple waypoints which represent the green circles, and the yellow path is the direct path from each waypoint, and the purple path is the path that the RC car took. And as you can see, it's pretty accurate, and it's able to get centimeter level accuracy, but of course you need a long survey time. And so that kind of wraps up our GPS performance. And now, Rema, you.
So I'm going to talk about the human detection. And so this is a device that's supposed to track a 5K runner. And before you can track a runner, you have to first identify them. So we tried multiple methods to make sure we were using the best way possible to track, and we weren't doing too much work for a little outcome. So first we tried color tracking. And now color tracking didn't really work because it's very vulnerable to lighting. So if it's cloudy, the color and the hue and saturation might change, and so it's not very good. And then we tried a system called April tag detection. Now April tags are these barcode-like things, and we use open source software online that could detect these things and tell you the distance from the April tag to the camera. Now this was a problem because it's very vulnerable to obstruction, and so we predicted the runners were going to be moving a lot and turning a lot, and so because of that, the camera might not be able to spot the April tag all the time. So we wanted a more robust method, and so we moved on to machine learning. And so we needed a lot of data, so we thought hard of where we could find the data, and we decided a database that's very available is pedestrian data. So we trained a support vector machine, or we got a pre-trained model of a support vector machine. We chose a support vector machine because it runs really fast. And so it was trained on a lot of pedestrian data. So it's very reliable, very fast, and it can also track people from the front, from the side, from the back, and everywhere. And this was good because we custom built a pan tilt system where the camera can move in 360. So you could do cool pan shots where the robot moves and the camera kind of follows the runner from the front all the way to the back and has a nice cinematic effect. And so when we set out, our goals were we wanted autonomous navigation, we wanted autonomous tracking, we wanted to be able to last for 30 minutes and also identify the runner throughout the race. And so we ended up doing all those things, and then we ended up using the human detection with AI, which is machine learning, and we ended up being able to run it for 50 minutes straight. Now the average 5K run is about 30 to 40 minutes, so we have a robot going for 50 minutes, so it can track from a really fast person to a slow person as well. And also we had added wireless streaming, so we added a GoPro as well. So our system works with multiple USB cameras. It could also work with GoPros, and you can use two of them together, so you can wireless stream from the GoPro and use the actual camera for tracking. And I just want to say, and then we designed a PID control system for the speed of the robot. And I just want to say, this can be used for multiple things, not just tracking the 5K run, but everything where you need a camera. Thank you. Any questions? Yes.
Used for a training run, not necessarily with the GPS function, but could you run a random course and the thing would follow you or run in front of you or whatever?
Yes, so you can run a random course if there are no obstacles. So it will stop if the runner stops, and if there's free space, it will just match the speed of the runner. And so if there are no obstacles, you can do it without having a GPS navigation.
Could it track a tennis game?
A tennis game, you would need to change things up a little bit, because this time it's only programmed to be looking at one person, like one person is supposed to be in the frame.
Say you had two.
Oh, okay, yes, so if it's just one, so if you're just tracking one side, it could definitely track a tennis game,
So
yes.
you could track the form.
Yes, yes.
What is the cost for the program?
So it cost about $1,300 because the computer we used was expensive, and the RC car and the battery and all of that. But to people who like hire cameramen and like pay them for days, it's like a lot cheaper than like actually getting a cameraman. Just, yeah.
It's like